Alright guys, this video is for Algebra 2 NTI days 33 and 34. On both of these days, you are working to go from a factor like this to a zero. And we've done a lot of this before when we were talking about quadratics. So this part isn't really too new. There are some new vocabulary words that you need to make sure you know what those mean. On 33, the new vocabulary word is multiplicity. So multiplicity just means that a zero counts more than one time. And I'm going to show you how this one here has a multiplicity. And really, any zero has a multiplicity if it has an exponent back here. So this one is going to have a multiplicity of 2 because the exponent is 2. Just like when you guys were finding the total zeros, that biggest exponent tells you how many there are. So this is just saying, okay, there's really just one zero, but it counts twice and makes there be 2. Because this expression is the same as this, because we're squaring it, which means that we're multiplying it by itself. So thinking back to when we did this before in quadratics, if we just have x plus a number or x minus a number, all we have to do is flip the sign. So that'll change to -7, and this will as well, because it's the exact same thing. So our zero is the same number, but it really counts 2 times. So we would say -7 multiplicity 2. On the graph, you would see that, let's just say this point right here is at -7. We would see that where the graph doesn't go through at -7, but it just glides right there on that x-axis and makes it count twice. So anytime that you have an exponent out there, it's going to count 2 times. On to day 34, you get some more vocabulary words, and that's just classifying our zeros. So far we looked at real and non-real zeros. We can also have rational zeros. And -7 is a rational number. A rational number is like any integer. So any like whole number, it can be positive or negative. It's rational. It's any number that can be written in a simple fraction. So like 1/2 or 3/4 or 5/3 or 6/7, and so on and so on. So that also means anytime you see a short decimal or a repeating decimal, so like 0.2, that can be rewritten as a fraction. 0.33 repeating, that can be written as a fraction. All of those are rational numbers. The next type of zero is irrational. And that's when you get some kind of number that cannot be written as a simple fraction. Your irrational numbers can be in a fraction, but it's not a simple fraction. So it would have like a square root in the fraction, or it might have something else weird in the fraction. Irrational numbers are also, I can't remember if I already said it, long, crazy decimals. So a lot of times it'll be a number in a radical as long as it's not a perfect square. So if you were to type in the square root of 5 in the calculator, you'd get this crazy decimal. Or like the square root of 21 or something like that. The number pi is also an irrational number. The square root of 64, though, is equal to 8. So that one is actually a rational number. And then the last one there is non-real, and we've talked about that before. So anytime you have something with an I, is going to turn it into an with an I is a non-real or imaginary zero. So a lot of times when you're working these out, if you don't have an x squared, so if you don't have something like that, it's going to be rational. So I'm just going to make up one here and hope that you don't have the same one on your paper. So we're going to look at this one first, and then we'll go up here and talk about that one. So look in here, 2x plus 5, and we've done ones like this before. We still flip that sign, so a negative, and then this is going to make a fraction. this back number is always my top number. This number here is always my bottom number. So negative 5 over 2 would be the solution for that, which is a rational number because it can be rewritten as a simple fraction. Well, it already is in a simple fraction. When we come up to this one, and anytime that we have the x squared on the inside, so that's different from these that we did up here. The x squared on the outside just says, sure, go ahead, you can flip that sign, make it count twice. The x squared on the inside says we need to work it out. So we'll set it equal to 0. And remember, you could set all of these equal to 0 and get the same thing. If I set this equal to 0 and solved it, that's the number that I would get. So this is set equal to 0. I need to get x by itself, minus 3. To get x squared is equal to a negative 3. And then I'm going to go ahead and take the square root. So I know when I take the square root of a number, I'm always going to have two solutions. I'm going to have the positive one and the negative one. So I'm going to go ahead and put 2x equals because I have two solutions. I'm taking the square root of a negative, so I know it's going to be imaginary. So I'm going to go ahead and put the I, and then the square root of 3, I don't know what that is, so I'm just going to put square root of 3. I'm just going to leave it. It's not a perfect square. Oops, and this one should be negative. So I square root of 3 and negative I square root of 3. Or if I wanted to write it one time, I could do plus or minus I square root of 3. Because it has that I on it, that imaginary number, it is a non-real 0. If I have something like this, I hope I didn't give you that one. Let me check. Ooh, I did. Let's make that a 13. Okay, so my square is on the inside. I'm going to do the same thing. X squared minus 13 is equal to 0. I have to solve for x. So I'll add the 13. X squared is equal to 13. My next step is to take the square root. I know I'm going to have two solutions, and it's positive on the inside, so I don't have to worry about bringing out an I or anything, but I know I'll have a positive one and a negative one. The square root of 13, I don't know what that is, so I'm just going to leave it in the square root. Or I could rewrite it one time as x equals plus or minus square root of 13. So I have those two solutions. I don't know the square root of 13. If I type it in the calculator, I'm going to get this crazy long decimal. So this one would be an irrational solution. Also, as you are working on day 34, I know it's kind of set up in this table. So if you want to set your paper up and like number on the side or whatever, and then you can put your answer. So number 1 is already done for you, so I'm just going to show you with number 1. So negative 3 over 2 multiplicity of 2, and then just make another column and put the R for rational. And then number 2 the same way, like you could do plus or minus square root of 5. You would get a long crazy decimal there, and so it would be irrational, and then so on. And that would probably be the best way to copy that down onto your paper. Hope that helped.